Hi, this is Miss Bichelle, and I'm going to be going over the 7.1 notes over transformations and graphing of rational functions. Before we actually look at rational graphs, we're going to go back to what we looked at ninth grade, which are quadratics and exponentials. If you remember with a quadratic, it's this U shape, maybe, that has the symmetry. Okay, so I can draw that vertical line, which we call the axis of symmetry. It has that vertex, which is the highest or lowest point. And those were some of the special characteristics of a parabola. We also looked at this formula that is called vertex form, because I can easily plug in my vertex. So let's go look at this first middle example. Okay, the red right here is called my parent function. Okay, means nothing special has happened to it, no transformations. My vertex is at 0, 0. It's opening up. Now, if I look at my green parabola, okay, I have moved it. So how I have moved from the red to the green is I went to the right 1, 2, 3, 4, 5. So I'm going to come down here, right 5. And then we've gone down 2. In ninth grade, we took these transformations. We also took the vertex of the green, which is 5, -2, and we plugged it back into the formula. So let's name this guy m of x. So I'm going to have m of x equals, my a is 1 because my parabola is opening up, so it's positive. Okay. I'm always going to have my x there. My h, okay, is I take the opposite of my x. So instead of having +5, I'm going to do -5 squared -2. And that's what we did in ninth grade. Hopefully you remember that. Let's look at our third one. Okay, so my parent function again is this red parabola starting at 0, 0 for my vertex and opening up. My transformed parabola, is now opening down. Okay, so if you remember, we called this is a reflection over the x-axis. Okay, so that's what makes it opening down. To go from 0, 0 to my new vertex, I'm going to the left 1, 2, 3, 4. Okay, so left 4. And then we're going up 1, 2, 3. All right, so my vertex is -4 and a +3. All right, this time when I'm plugging it into my formula, I'm going to tell you why we take the opposite. So I'm going to use my vertex formula. Let's just say n of x this time. So I have n of x equals, my a is actually going to be -1 because my parabola is opening down. Okay, and then I'm going to have x. In the formula, we always have minus, so I'm going to put a minus there. Okay, and I'm going to plug in the vertex. So it's a -4 and then +3. So if you look inside my parentheses, my final formula, I'm going to be left with n of x equals -1 times x plus 4 squared plus 3. All right, so that's why we're doing the opposite, because your formula always has that negative. All right, let's go look at exponentials. Okay, so here I have my exponential equation g of x equals a times 2 to the x minus h plus k. Now, right here, we're just going to keep the base as 2. And my parent function for that is right here. Boop, boop. And my y-intercept is at 0, 1. Okay, in ninth grade, all we dealt with was vertical transformations because the vertical transformation had to deal with the asymptote. So if you remember, there is this horizontal line, which this is called y equals 0 because it's going through the 0, that my parent function, will approach but never touch. Okay, so when I'm looking at my green one, the one that has been transformed, okay, I'm like, okay, to go from red to green, all we did was go up 1, 2, 3, 4, 5. And now my new asymptote is y equals 5. So the horizontal asymptote moved up that exponential. So transformation is move up 5. For my formula, we're going to have, let's do h of x this time. Since my slope is positive, because I'm going up from left to right, my a is going to be 1. We're going to keep that as 2. We did not do anything with left to right transformation with exponential, so we're just going to leave this as x and actually have no h. And then I'm going to have plus 5. So that was my exponential. And if you remember, we specifically talked about that big plus or minus being that asymptote for your exponential. All right, my third graph, okay, this exponential, my parent function again is in red, okay, going where my y-intercept is going through 0, 1, and my asymptote, that line that it'll approach but never touch, is y equals 0. So to get from red to green, I see that it moved down 2. So we went down 1, 2. I'm sorry. We went down 1, 2. We actually went down 3. So my new asymptote is y equals -3. So transformations down 3. And for my equation, so I'm going to have j of x equals 1 times 2 to the x, and then my asymptote is -3. All right. The reason that we're looking back at these functions is, 1, because we're still going to be looking at our a, h, and k for transformations. Okay. And 2, rational functions also have asymptotes. So I wanted to remind you of, hey, you have looked at asymptotes with exponentials before. So here's what our rational functions look like. Here's the formula. H of x equals a over x minus h plus k. My a still means the same thing that it did with quadratics and with exponentials. If my a is positive, okay, there's no transformation. If my a is negative, that means that there is a reflection over the x-axis. My h is all about my horizontal shift, moving left to right, and my k is all about moving up or down. Okay, and this is what the graph looks like. Okay, with a rational function, I actually have 2 asymptotes. I have this one right here, okay, that is at y equals 0. So that's my horizontal asymptote. And then now we have a second asymptote, okay, that is vertical, that is x equals 0. Okay, so we're going to start looking for these. All right, so looking at my first example of this rational function, again, my parent function is in red, okay, and I'm like, okay, what's happening from my red to the bluish purple? And I see, hey, I'm going down. I don't know why I keep 1, 2, 3, 4, 5. Okay, so my new horizontal asymptote is y equals -5. Okay, so we went down 5. If I look at my third one, okay, so here's my parent function. Okay, and I notice we're not going down at all. I'm actually going to the left. So I'm going to the left 1, 2, 3, 4. So this one is x equals -4, or I went to the left 4.